Dart School presents probability. Probability is the chance of something happening. It can be expressed as a fraction or a decimal or its equivalent percentage. As a fraction or a decimal, the probability of something happening or the chance of something happening is always greater than or equal to 0 and less than or equal to 1. As a percentage, the probability is always greater than or equal to 0% and less than or equal to 100%. When the chance of something happening is 0, we call that an impossible event. For example, if you are asked to pick an even number, the chance of picking an odd number is 0. And when the probability is 1 whole or 100%, we call that a certain event. It's sure to happen. You could say that probability of all human beings dying someday is 1 or 100%, and that's a certain event to happen. In maths, the probability of something happening is defined as the number of ways in which an event can happen divided by the total number of possibilities. Total number of possibilities. Imagine you are throwing a dice and you want to find out the probability that the number that shows up on the top is a multiple of, let's say, 3. Now, if you're throwing a dice has got 6 faces with the numbers 1 through 6 on its faces. So the multiples of 3 are 3 and 6. The number of ways in which it can happen is 2 ways. Either it could show up a 3 or it could show up a 6. Out of the total number of possibilities, of course, is 6. It can be any number from 1 through 6. So this is going to be 2 over 6 as a fraction, and that simplifies to 1/3. You could also find the probability of something happening by performing an experiment, and the probability in that case is given by something called relative frequency. Relative frequency, and that is given by number of times the event actually happens whereas in the mathematical formula you have the number of ways in which the event can happen. This is the number of times it actually happens divided by the total number of times the experiment was done. So if you were to find out the probability that a multiple of 3 shows up when you throw a dice using this formula, you would go on to record the outcomes. How many times it actually showed a 3 or a 6 out of the total number of times you throw the dice. And as you keep rolling the dice over and over again, this total number of times the experiment was done keeps going up. And when you do that a large number of times, you will see that this fraction out here that was recorded will be approaching closer and closer to this fraction 1/3 that's given by the formula. Let's look at a couple of problems now. A bag contains 6 white and 6 black balls. If a ball is picked from the bag at random, what is the probability that the chosen ball is black in color? This word random means without any preference. So as if the person who is picking the ball is not looking into the bag, so no preference is given either to white or to black balls. And in this case, the required probability, P black, that a black ball is chosen, is equal to the number of ways you could choose a black ball, that's 6 ways because there are 6 black balls, over the total number of ways you could pick a ball from the bag, that's 6 plus 6, that's 12. And if you simplify this, you get 1/2. And that's pretty obvious, isn't it? There are equal number of white and black balls in the bag, and therefore each one is going to get you a probability of 1/2. Let's try another one. There are 3 red, 4 blue, and 5 yellow balloons in a sack. If a balloon is chosen at random, what is the probability that the chosen balloon is not blue in color? And this time, P not blue is going to be equal to the number of ways you could pick a balloon that is not blue in color. So that could be either red, 3, or 5 more ways for yellow. So we have 3 plus 5 on the numerator over the total number of ways a balloon could be picked from the sack, that's 3 plus 4 plus 5. And this is equal to 8 on the top, 12 on the bottom, that simplifies to 2/3. So the probability that the chosen balloon is not blue in color is 2/3. Let's try another one. If A is in a room in 75% of the cases, and also if B is in the same room in 80% of the cases, what is the likely percentage that only one of them will be in the room at a given point in time? So there are 2 persons, A and B, and A is in the room in 75% of the cases is just another way of saying that the probability or chance of finding A in this room is 75%. And that translates to, so you could say PA, the probability of finding A in the room is 75% or 75 over 100. And that simplifies to 3/4. So the probability that A is in this room is 3/4. Similarly, the probability that B is in this room is 80% or 80 over 100, which is equal to 4/5. Now we need to find the likely percentage. That means we need to find the probability and express it in percentage. Probability, likelihood is the same as probability. Probability in percentage. Of what? Of the event that only one of them will be in the room at a given point in time or at the same time. So it's either A and not B in the room, or B and not A in the room. If this happens, this is not going to happen. If this happens, this is not going to happen. They are called mutually exclusive events. And to find the probability of this either or scenario, either this happens or this happens, and they cannot happen both at the same time, you find out the probability of this and find out the probability of this and add them together. So the probability that A is present is already given, it's 3/4, and B is not present. The probability that B is present is 4/5, therefore B is not present is 1 minus 4/5. Remember, the whole thing is a 1 if you are expressing the probabilities as fractions. So times 1 minus 4/5 is 1/5. Similarly, the probability that B is present is 4/5 multiplied with not A is 1 minus 3/4, that's 1/4. So this is going to be equal to 3 over 4 times 5, that's 20, plus 4 over 5 times 4, that's 4/20. So that's equal to 3 plus 4, that's 7 over 20. One final step is to express this as a percentage. Multiply this with 100 and you get 35%. Cross off the 20 with the 100. 20 times 5 is 100. 7 times 5 is 35. So the likely percentage that only one of them will be in the room is 35%.